Have you ever stopped to think about what's really powering our world? I mean, everything we do. It's not just the internet. It's something microscopic, unbelievably complex, and right now, it's at the heart of a massive global race. So let's dive in. We're going to pull back the curtain on the semiconductor industry, the trillion-dollar engine that's hiding in plain sight. First up, let's just talk about the sheer scale here. This is not a niche market. By 2030, the global semiconductor market is projected to absolutely rocket past $1 trillion. Now, to put that into perspective, that's nearly doubling in just a few years from where it is today. We're not talking about simple growth here. This is a flat-out explosion. So that begs the obvious question, right? What in the world is lighting the fuse on this rocket ship? Well, it's not just one thing. It's more like a perfect storm of crazy innovation and incredible demand that is, and I mean this literally, reshaping our future. Let's break down what's really driving this incredible surge. To really get this boom, you first have to understand the chip itself. We call them semiconductors or chips, but really they're the basic building blocks for all modern electronics. They are the invisible brains inside your phone, your car, the giant data centers that run the entire internet. They are quite literally the engine of our modern lives. Okay, so let's get specific. There are two just colossal forces driving this demand way more than anything else. First, you've got the absolutely insatiable appetite of artificial intelligence. And second, there's the complete transformation of the car industry. These two sectors are on a collision course with the future, and they need a whole lot of chips to get there. So, how do these two stack up? Well, on one side, you have AI, which needs these massive, powerful brains. We're talking specialized chips that can fill up entire data centers just to learn and process information. And then on the other side, you've got cars, which are evolving so fast from just being simple machines into these high-performance, data-crunching computers on wheels. Both of them are just demanding more and more silicon. And you know what? The numbers totally back this up. Just look at this chart showing where all that growth is coming from. Server and network, that's the heart of AI, and automotive. They are projected to be the two fastest growing areas all the way through 2030. We're talking about AI-related demand growing at almost 12% a year, with cars right behind it at over 10%. This isn't just a guess, it's the trend that's shaping the entire industry. This quote really just nails the whole shift. Think about that for a second. A car is no longer just a mechanical thing. It's being completely reimagined as a high-performance computer on wheels. Every single new feature, from advanced safety systems to the infotainment screen, is all powered by this incredible digital transformation. And this is where you really see the economic impact. It's wild. As we move up the ladder of self-driving cars, the value of the chips inside a single car just skyrockets. A car with what's called Level 2 autonomy, think of it as advanced cruise control, already has up to $2,000 worth of chips. But jump to Level 4 high automation, and that value more than doubles to $5,000, maybe even more. That is a huge jump for every single vehicle. Now let's pivot back to that other giant, AI. The amount of power these systems need is, well, it's staggering. AI data centers are on track to more than double their energy use by 2030. This creates a massive problem, right? How do you get more and more computing power without basically causing a brownout for the entire electrical grid? The only answer is a brand new generation of chips that are not just more powerful, but radically more efficient. Okay, so we've got this insane demand, but what about the supply? See, this is where the story gets really, really interesting. This isn't just about factories pumping out parts. This is a high-stakes, global geopolitical race for technological supremacy. Because building these things is one of the most complex manufacturing processes on the entire planet. You see, to make chips more powerful, you have to shrink the little switches on them called transistors. But we basically hit a wall on how small you can make something on a flat surface. So as you can see on this timeline, engineers had to start building up. Think of it like going from a one-story ranch house to a full-blown skyscraper. We went from flat, planar designs to these 3D structures that stick up like a shark's fin, and now to designs where the transistors are wrapped on all sides. Each step is a monumental feat of engineering, all just to cram billions more of these things into the same tiny space. This whole race has created these very distinct strategies for the major players. You have the United States, which has always been the leader in designing chips. So its strategy now is to use things like the CHIPS Act to bring advanced manufacturing back home. Then you have Taiwan, the undisputed king of actually making the most advanced chips, and their goal is just to stay on top.
And then there's China, which is using its massive scale to build up huge capacity in the more established chip technologies, all in a major push for self-sufficiency.
So how do you even build these microscopic skyscrapers? You need this almost magical tool called EUV lithography. Try to imagine a printing press that is so precise it could etch the entire text of a novel onto a single grain of rice. That is the insane level of precision we're talking about here. It is the absolute key to pushing the boundaries of what's even possible.
And here's the kicker. The entire multi-trillion-dollar future of advanced computing, of AI, of autonomous vehicles, all of it depends on this one single technology. And there is only one company on the entire planet, ASML in the Netherlands, that can build the machines that do it. Talk about a supply chain bottleneck of epic proportions. So, keeping this intense race for production in mind, let's look ahead for a minute. Where is all this technology actually taking us? Because these chips aren't just for making our phones a little bit faster. They are the essential building blocks for technologies that, honestly, until very recently, felt like pure science fiction.
So what does all this actually enable? I mean, we're talking about the building blocks for true artificial general intelligence, a world with fully driverless cars on our roads, humanoid robots working right alongside us. These new chips will power the fusion of classical and quantum computing, and even brain-computer interfaces that could connect our minds directly to machines. Every single one of these world-changing breakthroughs depends entirely on the next big leap in semiconductor technology.
So as we wrap this up, it is crystal clear that these microscopic transistors are so much more than just technology. They are the fundamental building blocks of the world we are all about to live in. And that leaves us with one final, absolutely critical question that is going to define this century. In this global race, who will be the one to build that future?